Hello and welcome to session 288 in the AISafety.com reading group. Tonight, Rocco Michis will present his work, Credibly Safe AI. Pleased to have you here. I should introduce the speaker as well. Rocco Michis is a technologist and philosopher and the founder of Credibly Safe, Credibly Benign Artificial Superintelligence, I believe the organization
Yeah,
is.
that's correct. Benign artificial superintelligence, and the document we're working on is Credibly Safe AI at the moment. Thank you.
Wonderful.
Yeah, so let me just say a little bit about myself and the history, my sort of historical involvement in this. So I've been involved in, I would guess you could say, the online AI safety community since the very early days, probably since about 2006, 2007. And obviously that's quite a long time ago now. That's nearly 20 years. I've watched the field evolve. I've watched the technical field evolve as the discussion around AI risk has evolved. And I think there are some things that we're sort of missing, in terms of the risks of AI. So there are a lot of possible things that could go wrong with artificial intelligence. And people have talked a lot about some of them. So, for example, you could have an AI system where a rogue terrorist or maybe like a terrorist organization or a lunatic uses that AI system to do something bad. You could have the paperclip maximizer scenario where an AI starts to pursue goals of its own, which are unintended by its creator. So this is sort of misalignment. But actually, I think the consideration of sort of, lab escape / misalignment risks and lone wolf risks are probably not the actual risks of this technology that are most important. And I think, the sort of consideration that those risks have been given reflects a combination of historical accidents in the way the field has evolved with sort of human biases for, what Bruce Schneier might call sort of movie plot scenarios, right? And some of them are indeed movie plots, like the movie Terminator. Literally has a scenario where an AI system breaks out and takes over the world and kills everyone. I don't think those scenarios are impossible. I just think they're unlikely. I think the more likely scenarios, in order to really evaluate what the more likely scenarios are, we should be looking at actual world history rather than movies or internet forums. And if you look at the historical development of technology, a lot of the disasters that we have had historically have come from game theory problems, have come from basically bargaining problems, where a new technology is introduced, it creates a strategic situation which is unstable, and that instability results either in a war or it results in some kind of near miss. So probably, people might not think so much of railways as an existential risk, but in fact, I think it's not too much of a stretch to say that railways caused an existential disaster that ended Western civilization, right? And you might think, how can that possibly be the case? When did the railways take over? Well, it turns out that in 1914, World War I happened because the development of the Russian railway system resulted in a strategic instability where Russia's power to mobilize was increasing as a function of time more quickly than Germany's was. And so it became in Germany's interest to start a war, and that war was World War I, and it destroyed the Austro-Hungarian Empire, it destroyed Germany, it set the stage for World War II, it destroyed the British Empire, basically caused, a sort of quasi-civilizational collapse of European civilization. And why did it happen? Well, okay, I mean, that's one thing that contributed to World War I, but I think it's a very important one. There was a new set of technologies were introduced, industrial warfare. They had huge risks attached to them that people weren't really paying enough attention to, and they created strategic instability. Another one is perhaps the next big conflict, which was the Cold War, and the risks community, the EA community, the AI risk community is sort of more in touch with these. So you had things like the Cuban Missile Crisis, and a lot of people are still not aware, but during the Cuban Missile Crisis, US ships started firing depth charges at a Russian submarine that was equipped with a nuclear torpedo at the height of a nuclear standoff. And the captain of that submarine wanted to launch a, like 30 kiloton, roughly sized nuclear tipped torpedo into the center of a US carrier group, which probably would have precipitated World War III. Now, it didn't happen, but it was, it was a matter of different personalities and people literally having an argument on board a submarine about whether to start World War III. Like, if it gets to that stage, you've passed quite a significant risk event. So I do think that, the strategic implications of AI, the instabilities that it can cause, are perhaps more important than the technical problem of aligning AI, although I do think the technical problem of aligning AI is an important one. So I think more people should work on these strategic considerations, the realistic possibilities for misuse, and also, realistic possibilities for complete abandonment of the technology, as happened with nuclear technology. So, we developed nuclear technology. A lot of people were very concerned. Well, to start with, people were buying like nuclear toothpaste and like radioactive cutlery and underwear and stuff in the 1920s. But once they realized that radioactive underwear was a bad idea, and people had their jaws fall off and stuff like that, they got very scared of it, especially after the development of nuclear bombs. And so there was a movement towards limiting the potential risks of nuclear power. And the result of that movement was that we still have large nuclear arsenals. We still have a nuclear standoff between Russia, China, and America. During the Ukraine war, Russian state TV threatened England with an attack by, thermonuclear weapons in the, 100 megaton range, and said we'll turn Britain into a radioactive wasteland if you don't pull out of Ukraine. Now, that was probably, to some degree an empty threat, but it's certainly not good that people are making those threats. So we have nuclear weapons, we have risks associated with nuclear weapons, but what the nuclear risks movement succeeded in doing was preventing the peaceful use of nuclear power, right? So we set up regulatory agencies, and they misregulated it, and we've basically stopped building nuclear power, and as a result of that, our civilization has fallen behind where it should be. Right? We're not producing enough energy. We have food and energy shortages. Industry in Europe is collapsing right now because of a lack of energy, which is partly because we didn't build nuclear power plants. I think we have some background noise from Chris.
Sorry. Sorry.
But actually, that's a good point. If anyone has any questions about what I've said so far, please go ahead.
I have a number of questions, but they're more about like zero knowledge, machine learning, and the text.
Yeah. So, having said all of this, I think that the issues to do with the game theory of AI are understudied, right? We are rapidly moving into a world where humans are no longer going to be the most capable type of intelligent being on the planet. A lot of actors, to start with a few, but over time more, are going to have access to these artificial intelligences and also robots and drones. And that's going to usher in a new period of conflict, potentially. That conflict could go badly. There are a lot of things that could go wrong, and there's also the possibility of overregulation because we can't properly handle the risks, causing a civilizational collapse by default. So we have a problem at the moment with collapsing birth rates, dysgenics, global IQ is falling because people in the developed world aren't having children. So I don't think it's viable or desirable to abandon the technology completely. It may basically be our only lifeline to get to an infinite positive future, or sort of basically the future where humanity colonizes the galaxy is probably gated behind AI. There's probably no other way that it happens, at least as far as I can see. So solving the strategic problems around AI is pretty serious. So what can we do with this? Well, let me see if I can share my screen right now. So I'll just take us through. And Soren, can you say? Can you just tell me if you are seeing this correctly?
So I'm still seeing your video feed. So
Okay.
I'm not seeing the chat screen.
Let me just check.
Soren,
Is it updated yet?
I can see the shared screen.
Other people can see the chat screen. Interesting. Let me see if I can do something about that.
Yeah, it's showing both.
Wonderful. Yeah, I
It's
am
showing
now
both
in-
his screen and Ralph.
Yes. So I'm seeing your screen now, Rocco. Please continue.
Okay, great. Okay, so I think one possible way that we can, attack some of these problems is using a sort of advantage that's been given to us by artificial intelligence compared to humans. So humans are incredible. And I mean that they're incredible in the sense that if a human says something to you, like they say, I'm definitely not going to cheat on the exam, or I'm definitely not going to renege on this deal, that's incredible. You don't know credibly whether they actually mean that, right? They could be lying. AI systems, so humans do all the computation in our brains in this sort of meat, like neuron activations and, ion channels depolarizing and stuff like that, whereas AI systems do it in silicon, and digital computations that are done in silicon, can have these things called proofs associated with them, where you can prove that a certain computation has in fact occurred. So I spoke a little bit about, some of these risks. When you have, let me just scroll down to get to the interesting stuff. When you have a model that's running in silicon, you can create either a zero knowledge or an optimistic proof that a certain model was actually run, and you can prove that it has certain properties. Humans with sort of human thoughts are not capable of doing this. So using these types of proofs, you could have a situation where, say, an AI system from one country or one company or one strategic actor could submit a continuous stream of proofs to a blockchain, which proved mathematically that it had certain properties. For example, the model that was running could be checked with some kind of... sorry, we seem to have some background noise from somebody again. I don't know who it is. Let me just check. Yeah, I think it's gone. So you could have a mathematical proof submitted that a model isn't lying, or that some kind of lie detector probe has come up negative. Of course, these probes themselves are not necessarily going to work 100% of the time. You can have the proof. You could have a proof that the prompt that was given to a model wasn't in some way aggressive, so it didn't ask for somebody to be harmed. You could have proof that the output from the model passed some kind of check, that it didn't involve plans to harm people or something like that. And these kinds of checks could eventually be incorporated into the hardware that we run AI systems on in the end, so that they actually won't run unless these checks have passed, right? So, this kind of paradigm of zero knowledge machine learning allows us to change the strategic landscape to one where, actors can actually make credible commitments. And if you had these kind of credible commitments, and let me just go back to video, if you'd had these kind of credible commitments in, say, 1914, countries could have committed to not invading each other, right? Which would have been better for everybody. Nobody, it's a war that nobody wanted, right? It's just a pure war from instability. If you could have had, say, the German High Command and the Russian High Command just submit these continuous string of proofs onto a public blockchain, assuming blockchains magically existed in 1914, they could have just sort of had these proofs that they weren't about to enact a war plan and thus avert the war. So I think that's a good intuition pump for the kinds of things you could do if you could create these proofs. And you can, right? People are already creating zero-knowledge proofs to prove AI behavior. They're also creating optimistic proofs, which don't have as much of a technical requirement, but they have much more privacy preservation. So there's a company called HyperOracle that's already doing that with something called OpML, which is actually quite a simple system. So, given what I've just said, Soren, do you want to ask any questions, or does anyone else want to ask any questions just to have a brief pause for people to digest what I've said?
Well, there are some questions in the chat. I don't know, Emily, would you like to pose your question directly? I don't know if Emily's microphone.
Hey,
Yeah.
yes, can you hear me now?
I can hear you.
Yes, so in terms of the zero knowledge checker, right? My understanding is that you have a model and you know what its output is supposed to be, right?
Mhm.
So, but then you said that the model has to be run at some point, right?
Right.
Before putting it into the checker. But like, the first time the model is run, like how do you know that that model is safe? Because, the first time we tested a nuclear bomb, right? We didn't know if it was safe or not, right?
Right. Okay. So you could have a case where something is sort of instantly dangerous, but I think that's quite unlikely. I think in reality, risks from AI are going to be a whole series of millions of different inferences. Think about so this can be done on an inference by inference basis. So as soon as you've had one forward pass through a model, you can produce a proof that y equals f of x, where y is the output, f is the model, and x is the input. And you can also output proofs for various checkers that have been run on that input and output as well. And I think any kind of realistic risk is going to involve millions or billions or trillions of these forward passes. Just like an invasion, it's not like one person says a single word or a single sentence and that's enough to create a military invasion, right? You have to have many, many people doing many different things and checking them and considering different plans. So the whole thing has a really huge mental footprint. So I think this idea that a single forward pass is going to be instantly lethal for the world is a notion from old school, less wrong AI risk thinking, and it's probably not appropriate for the world that we actually live in.
So what type of proofs are you looking for?
So for as a specific example, the optimistic ML proofs will simply prove that y equals f of x. So if you have an output y, which could be, so let's say you have some kind of neural network, you think of it as a function f, you give it an input x, which could be a prompt, what's a good recipe for pancakes, right? And then, y is the output, which is like, well, first you get the flour and then the milk and so on and so forth, right? So you can post a proof that y is in fact equal to f of x, right? You can post that proof onto a blockchain, and it's like quite a small proof, right? So, anyone can check it. You could also have a secondary model that would run on that output and prove that that output doesn't contain the word gun, for example. Or you could have a more sophisticated model whose job is to detect whether a given output is, for example, a plan to start an invasion, or plausibly part of such a plan or something more complicated like that. And you can run these checks automatically, and then you can post the proofs on chain.
Okay, I have another question on that. I'll just share my screen to be able to. You should be able to see my screen now with a little luck. We'll see. Can you see my screen?
Not right now.
Not right now. I'll just see if I can.
There may be some latency on it.
So I'll check if you can now. You can see my screen? Okay, then.
I can't. Can anyone else? Oh no, I can now. Yeah.
Yes, wonderful. So okay, so now I'm going to the Windows Task Manager to prove a point. So this is, you should be able to see the Windows Task Manager coming up right here. And if you look at the programs that are actually currently running on my computer, there is one of them called MP Inch here, which is actually something kind of close to, I think, what you're envisioning. This is a program that is forced to run on my computer, that is using a machine learning model to scan my computer for whether there is some input that is coming in that is potentially dangerous, or my computer is sending something out that is potentially dangerous. And this is basically something that I think it is in fact still possible to turn off, but it would be reasonably trivial for Microsoft to just change this to be impossible for the end user to turn off. And this basically, it's also sending data to Microsoft right now. And so you could imagine this program just basically doing the work that you are talking about, but without any need for like zero knowledge machine learning, because this would just be this is monitoring everything that I'm doing on my computer right now. And if the TPUs are like, you can have drivers that are cryptographically signed and things like that. If this program just reported to some UN agency or something like that, then we could avoid doing anything with zero knowledge machine learning, as far as I can tell.
Yes, but you've introduced a trust assumption, which is that you have to trust Microsoft, right? There's a whole bunch of people in that chain who could cheat, and the fact that they could cheat maybe significantly diminishes the strategic value of it. You can't cheat math, right? So when you do a computation, you use a certain amount of energy to do that computation, and then you can post the proof, right? You can't cheat that process. It's kind of like you can't mine Bitcoin without spending a certain amount of energy. Whereas Microsoft could claim to have installed this checker software on somebody's system, but then actually not do that. And if the person you're trying to persuade is like Russia or China or a different AI company, then that difference can matter quite a lot. The other thing is, maybe actually you could have some kind of UN AI safety agency or something like that, such that all of these different actors actually do trust it and it doesn't cheat. You maybe could do that, but that then introduces risks of totalitarianism, because it basically means that everyone's systems would have to be locked down at a very severe level by a centralized authority, and a lot of people might not like that. Whereas if you use the math version, you remove those trust assumptions, so you just keep posting these proofs. Now, there is a downside with the math version, which is that you could simply do the bad thing and not post a proof, right? So you could calculate how to make a bioweapon using your AI system, and of course these checkers would all fail, but you just keep quiet about it, right? But, if you do that a lot, if you use a large fraction of your computation to do that, you're going to have a sort of obvious compute debt. So you can just sort of track how many of these computations everyone is expected to do given the amount of hardware they have. And if somebody sort of has a whole bunch of their hardware suddenly go dark, it's sort of obviously suspicious, right? If they were being honest, it would be in their interest to simply post these proofs. You can think of it as a hard to fake or well, in theory, impossible to fake inspection regime that people can sort of voluntarily opt into. And if they opt out, it's suspicious, and I think it is possible to adjust the rewards, shall we say, such that, for most of these actors, it's not profitable to opt out, right? They just want to opt in. And the reason that they would want to opt in is because you can have these actors negotiate an optimal policy for the collective utility of all the different actors, right? So, obviously that negotiation could break down, but assuming it doesn't, then they wouldn't want to opt out of it. But that's a good question. And I think that kind of gets at the core of what I'm talking about. And another important part is if it's based on math, I don't need to go and ask Microsoft and the UN for permission to do this, right? I can just start doing it.
All right. So okay. The idea is. Oh, go ahead, Soren.
I think Emily had a question. Well, it seems that this is still relying on the chip makers, right? They could make some chips on the black market. So there's still this one element of trust that is required.
You could have dark chips where people are doing a whole bunch of computations and simply not posting any proofs, and also not telling anyone about the existence of those chips. But I think it would in fact be very hard to keep the existence of such a system secret, because chip fabs are quite easy to spot, right? They're very big, they require a large physical footprint, they require quite a lot of energy, expertise, etc. So you would probably know if somebody had a big sort of pool of... And also the chips themselves are going to require a lot of physical power, right? Which is one of the reasons that it's hard to cheat on nuclear, international nuclear regulations, is that uranium separation plants require a large amount of physical power, right? And you can see that as a thermal signature. So if somebody has a large dark data center somewhere, you're probably going to notice, right?
Yeah, great. And just for the record, I'm trying to keep track of some kind of question queue. And right now, I think Ali is in front, and then Axel has raised his hand, and then Lau Mein has a question. Please post your question in the chat, and I'll try to keep an order. So Ali, could you state your question, please?
So I think parts of it have been addressed by other people, but I'm still not really understanding why these zero knowledge proofs, what these zero knowledge proofs are, or why they're sufficient. I can understand maybe how if you have a bunch of models that aren't really that powerful, and you train them and you expect, okay, things are going to gradually increase in capabilities from here. So if we just know what sorts of capability, okay, how should I say this? I'm not sure I'm explaining it right. At some point, I expect there to be models which are very, very powerful, right? Even if that happens gradually over the course of 2-3 decades, by that point in time, I expect them to be massively powerful. And I also expect us to, once we get to superhuman systems, I expect us to go from superhuman to very superhuman quite quickly. And I can see how your proposal would definitely help with giving us a lot more time, with probably the human level, where the systems probably aren't too powerful, they can't go boom or whatever, and we can just chuck them in the world, see what happens, what's very dangerous, what's not. Once we get some handle on what kinds of things are dangerous, we can just say, okay, you really should not be touching any of these class of inputs, otherwise you're fine. That seems all good, but I don't get how this helps with the models which are 1 or 2 years down the line after you get superhuman systems. And that's always felt like a sticker to me, because it seems like, I don't know, things are just going to fall into some kind of weird evolutionary equilibrium, or go into something that's a crazier version of Age of M by that point. And I'm not sure how this helps with that. I could understand if you had something like David Add's open agency framework, which is incredibly ambitious and would give you very strong guarantees over, I don't know, like pretty much arbitrary behavior. But it sounds like you're asking for something much less ambitious than that. And also that's the vibe I got from reading your post on Credibly Safe AI, because you said this is not a solution to alignment. It's a way to prevent not known safe inferences and training grounds from happening that is incentive compatible.
Yeah.
And it just feels like there was a bit of a discrepancy between the talk we got and what we read. So
right.
There were two thoughts.
What happens?
Sorry if I ran.
Yeah. So what happens when you get? Good question. What happens when you get strongly super intelligent systems? I think the solution to strongly superhuman systems is that their goal systems will be set with the help of systems that are less strongly superhuman, right? So if you get to a state of the world where you have a strongly superhuman AI system which you're not in control of and which is horribly misaligned, and that's probably like a broken state, but you just wouldn't let it get that bad, because that state would be bad from the point of view of all of the previous strategic entities, right? So if you go back to the World War I analogy, if you get to a state when the French and the Germans are fighting on the Western Front, and there's like 1 million people a day dying at Ypres or something, right? That's a pretty bad state. But if there had been a negotiation that had happened in early 1914, and that negotiation hadn't broken down, and the parties could make credible commitments, it simply wouldn't have gotten to that state, right? They would have engineered the world such that we never got there. So I think we just
never did.
It did because they couldn't make credible commitments, right? That's why it got to that state. Because
right, I have some more questions, but I think that I'll probably wait until other people are done with theirs. But I think I see the point you're getting at, but then, okay, sorry, I'll just let other people have it.
Okay, yeah. My question is, how does this?
Just quickly, we'll just take Axel's question first, and then your question.
Thank you. So you were talking about trust earlier, and I'm wondering who you propose that we trust with defining the very concrete checks that this system would be doing. And if we have, maybe a two-part question, if we have these defined checks, will they be public? Will it be something we know? And if so, won't there be a situation where some bad actors will be able to maybe have deceptive systems that can exactly
be able to sort of hack these checks? Yeah. So that is a kind of nasty question, because right now, if you were to post the checks publicly, then probably using black box gradient-based methods, a bad actor could come up with a prompt which passed the checks but was nevertheless actually bad, and that's just a property of the types of AI systems that we have, neural networks, gradient descent, all of this stuff is kind of not good for security. But what you can do is you can cryptographically commit to a set of checks by posting their hashes, and then those checks could run for, say, a month, and then you stop using them, and after you've stopped using them, you publicly post them, and you just continue this on a rolling basis, right? So this would prevent, or it would make it harder for bad actors to break them, but it would still preserve the credible neutrality of the system. Now, in terms of what the checks would be, I have a solution to who would decide that, but you would actually need somebody to do quite a lot of work modeling the effect of these checks on what AI models would be able to run, what effect that would have on the world. And that's quite a lot of work. Nobody's paying for that work to be done at the moment, right? So part of the reason why I would like to start a company to do this is somebody actually needs to, finance that and eventually extract profit from it to pay back the investors. But basically somebody needs to run quite a sophisticated world model with red team and a blue team that's going to work out what kind of checks do we need to run in order to be safe at a particular point in time.
So, okay, so my question is, how would this work in the modern paradigm of machine learning models? So let's say I'm building GPT-5 and then I am giving it all the text on the internet. So like what type of text would fail the checks as part of the
Do
learning
you mean
process?
text for training or do you mean text for inference?
I mean, aren't those the same thing? Oh,
No,
yeah.
training and inference are not the same thing.
Okay, so let's just say training.
Okay, so we should treat the two cases separately. Inference is actually probably the easier one to explain because inference is just computing a function y equals f of x, right?
Okay, so yeah, let's start with inference.
So you could have a bunch of different checks that check x. So if x is tell me how to commit a genocide, then that check should fail, right? And if x is like tell me how to make pancakes, then it should pass, right?
But it's not actually possible to train a machine learning model under its current paradigms to not fail at any point in its training.
Sorry, I didn't understand the question. What do you mean by...
I mean, like, so if you want to make ChatGPT like pass all of those checks, like you have to go through a period where you're training the model on all the text on the internet.
You're talking about training. I'm talking about inference, though. So the model already exists, right?
Okay, so the model already exists.
Inference is when you already have the model, F, and you're just interested in X, which is the prompt, and Y, which is the output.
Okay, but in order to get to X, you have to first train a base model that isn't RLHF.
So, all right. So now you're talking about the training period. Training is a little bit more complicated, but maybe we can just talk about inference first. So the way this would work at inference is you'll have inference time checks that check the input X, they'll check the output Y, and they'll also have certain probes to check that the model itself, that the sort of internals of the model aren't displaying signs of lying. So there are people who are working on ELK, elicitation of latent knowledge, mechanistic interpretability, stuff like that. Eventually, I presume those avenues of research may come up with checks that can provide useful insight into whether a model is engaging in deception. So those would have to pass as well. So that's what happens at inference. Now, training is a bit different. So how do you even train a model in the ZK paradigm, right? Well, people would want to know what the data set is, but for commercial confidentiality reasons, companies are not going to want to release the whole data set. So probably what would have to happen is a cryptographic commitment scheme where the company would commit to release a certain randomly chosen proportion of its data set. So, what they could do is they could take each 1/1000th of the data set and give it a different number or a different color or whatever, right? They would post hashes of all of those different chunks. Sorry, I just got to deal with my computer's running out of power. So they'd post hashes to each of those chunks, and then the community as a whole would choose a random number, presumably with like some kind of secure ceremony or something like that, where everyone could contribute entropy, and then they would randomly have to reveal one of those 1,000 chunks, random chunks of the training set, right? So this would allow the company to convince everybody that the training set was clean with high probability, right? Because if they had a lot of dirty, like, the dirty stuff could be like, child pornography or, how to like build lethal biotoxins and weapons and stuff. If there's a lot of that mixed into the data set and you randomly release 0.1% of it or 0.5% of it, you're probably going to get at least some fragments in that, right? So the company would be able to convince people the data set was clean, right? Now, once they convinced people the data set was clean, they would have to actually release the architecture of their model. And then once you knew the architecture and you had these cryptographic commitments of the data set, I believe it is possible to produce a ZK proof of the whole training run. So the whole process of gradient descent could be proved in ZK. So you could know that a certain data set with a certain architecture applied to it would produce a certain model. Now,
That, yeah, I'm still trying to figure out how this works, because once you do all of that, you still have the base model, which
yeah,
will tell you how to make bioweapons.
yes, the base model will be able to, so you've proven what you need to prove about the data set, but even with a clean data set, a sufficiently smart model will be able to work out how to hurt people. But you can then also prove that you've done fine-tuning, you can prove that you've done RLHF, you can cryptographically commit to the RLHF dataset, or maybe even release a substantial proportion of the RLHF dataset, because that's pretty important. And then you could run a bunch of tests on the RLHF model. So you would never release the base model, right? But, if you want to actually use the model after it's had the safety systems put onto it, the fine-tuning RLHF, whatever else you can do, right? Then you can always produce a cryptographic proof that the model you're running is the model that's had those safety precautions put onto it, right?
So
So you have the base model, which is dangerous, right? But you can prove you can never prove that you've deleted it, right? You can never prove that you've deleted the baseline model, but you can prove that you're not using it using the inference time proofs.
What? How? Okay, so let's say I spend like, okay, so let's say I have a data center. It's on 90% of the time, 10% of the time it's not for maintenance.
Mhm.
All right. I'm not sure what the proportion of training time to like use time is, but like I'm sure you can find enough time to like actually use the non-RLHF models, or maybe a model RLHF to do like naughty stuff.
Oh,
Like
okay. So
somewhere,
yeah, you could probably do that. You could probably slip in a small amount of time
or you can just
using.
use it. You could just run the model using like legacy TPUs or whatever.
Sure, you could probably. It's probably going to be very difficult to prevent people from spending any time at all running a bad quote unquote model, right? There's probably going to be ways for them to do it, even if it's like, you have a small number of legacy pieces of hardware that are like hidden in somebody's basement or something. I don't think you can stop that, but you can make it so that the vast majority of the inference time has to be spent using models that are proven safe. And in addition to that, the sort of final level of this is that we can use these proven safe models to construct a sort of trustless cyber police force that you can then say, okay, well, I've got this proven safe model. I'm going to give it some kind of oversight access to my networks, and it's going to go and check to see whether I'm doing this sort of illicit, naughty AI. And that would be a further disincentive to even think about doing that in the first place.
Okay, so what does this prevent over the current regime?
It prevents, for example, something like World War III, where China gets a whole bunch of these machine learning models and sets them to plan, how to kill everyone in America through a war, through nuclear weapons, bioweapons, whatever, right?
How does it stop that?
Because they won't be able to use the majority of their inference time to do that. Maybe they can use a very small amount, but then the American side, which can the defense side of this is legitimate, allowed computation, and that's going to then have a lot more compute than the offense side. And in addition, there's also going to be the possibility of a trustless sort of models that are this sort of like mathematically proven neutral agents that can go and check to see whether any of this bad stuff is actually happening. So they can physically check, they can control robots, they can be like a sort of, a bunch of robots traveling around the country controlled by these mathematically proven neutral models that are checking to see whether any such preparations are happening, checking for illicit data centers, etc. And I think the combination, so, if such a thing was found, it would be quite a negative consequence for the country or the entity that was doing it. So I think it's possible to make it so that the expected value of even trying it is negative.
I'm just not sure if the math works out. Like the vast majority of computers can be used in training of the models. So like,
why do you think the vast majority is going to be used in training? I think it's going to be more like 50-50 between training and inference, right?
Is that the current regime? Like, if I was trying to use like AI to build some crazy bioweapon system and okay, so if I was using AI to build some crazy bioweapon system, how many questions will I even ask this AI? Like, if I can't,
probably quite a lot.
well, okay.
I think the way AI is actually going to be dangerous is through multiple. It's not going to be a single inference that's going to be dangerous. It's going to be many millions or billions or trillions of inferences that are going to be used to plan some kind of attack, war.
No, I completely disagree. Like, here's a one like somewhat interesting idea where I can just ask, let's say, GPT-6, how do I make chronic wasting disease, but for humans? Like, what is the mRNA sequence I would need to make prions that would like be chronic wasting disease, but for humans and also airborne and also more virulent? Like that's one pass.
Yeah, but I mean, it would come up with an answer. You wouldn't know whether that was right. It may have guessed. It may have hallucinated. So you'd want to have a whole sequence of different prompts, like consider this, consider this. Like I think actual, real, capable AI plans are not single inferences. They're millions of inferences.
Okay, so
like imagine you're trying to do this. Yeah, go ahead.
Okay. Yeah, okay, so this model is...
Let me say something quickly. Imagine you're trying to do this with a human organization, right? Imagine you're trying to plan a war or a terrorist attack or something. You probably have a lot of people planning it for a long time, right? Considering
9/11 was planned by like 10 people and like, what, $500,000 or something like that?
So, Lamaine, could I move you to the back of the queue, please?
Okay, all right.
I have a question that is not directly related to this text, but to like some of your other thoughts on the relationship between alignment and control. And you are much more optimistic about control techniques than I am. And which control techniques are you optimistic about?
Okay, so we're sort of substantially changing the subject now.
Yes,
does anyone else have any questions about the utility of proofs for thoughts before we move on to control?
Fair.
Emily.
Yeah, I guess you talk about these proofs, but how do you know that they are computationally even feasible to even prove things? Because like for mechanistic interpretability, right, you have like very large models and it's kind of hard to prove things about neural networks if they can be function approximators for basically everything.
Well, it depends. So if you just want to prove, so right now, HyperOracle has released an on-chain AI oracle today, or I believe actually yesterday, that uses optimistic machine learning. So instead of zero knowledge, it's sort of full knowledge. So the computation has to be in the public. So it's incompatible with commercial secrets, but it's very computationally cheap. You basically do the AI computation, which can be very big and very expensive, and you basically construct what's called a Merkle tree from that, which is like a sort of hierarchical series of hashes that ends in a sort of a Merkle root, and you post that Merkle root, which is like the hash of 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 this huge sort of logarithmic sort of bisection of the computation. You post that Merkle root onto a blockchain, and then anyone else can redo the same procedure and recompute the Merkle root. And if you've cheated, then they're going to get a different answer than you, and they can challenge you, and the challenge process is very computationally cheap, because you just say, okay, we disagree about the root. Do we disagree about the left side or the right side? If we disagree about the left side, then we recursively repeat that process. And because because of sort of this process is like logarithmic, right? It just takes a logarithmic number of steps until you get down to like a single computation where the cheater is trying to say that 1 + 1 = 3, and then they're caught cheating, and then they have a deposit that they had to, a sort of a deposit that they had to put on chain into a smart contract, and their deposit is slashed. So basically, it is possible. It's already being done right now, and there are people who are working on the zero knowledge version of this as we speak, right? So there are paradigms within zero knowledge technology that work efficiently with neural networks. I'm a little bit behind on exactly how they work, but it's sort of like it sort of chains its way backwards through a network. So it sort of goes in the opposite. So inference goes forwards. The zero knowledge proof actually goes backwards through the network, and it's able to quite computationally. And obviously, the computational efficiency of these zero knowledge proofs is improving very rapidly at the moment, because it's a huge growth area of technology. But yes, I am confident that certainly the optimistic version is possible right now, and the zero knowledge version will be possible quite soon.
I guess quick follow-up. Do you have resources for zero knowledge proofs for AI stuff? Because you keep on mentioning it, and maybe after the call, I'd like to see them.
Yeah, there's some in the Twitter group that I've created, which I could just post into the chat quickly. Just 1 second. So I have a community on benign artificial superintelligence, and so we have ZKML endgame proving specialized zero knowledge proving with GKR, and I'll post that into the chat.
Thanks.
Okay. So I would like to pose my question, which is what kind of control techniques do you expect to scale, and would it be possible to have an AI to assist in these controls schedules like recursively, so we get higher and higher? And is that possible to have like with only control and not alignment? Like you would think if you have someone who is not aligned but who you control, who is designing like the next level of control, then since he's not aligned, he may it may introduce some kind of backdoor or sabotage. Like would you trust a control scheme that was created by someone you control who is not aligned with you?
Okay, so moving on to AI alignment versus AI control, which is a sort of different topic. I'm sort of bullish on AI control because we have a lot of empirical evidence from humans. Like humans are not aligned with each other, right? It is extremely rare for two humans to have basically the same utility function. It's far more common for humans to have different utility functions, and then we design a whole bunch of mechanisms that sort of align people's behaviors, despite them having different utility functions. So these are sort of control schemes. So the famous example from Buck at Redwood Research is Vladimir Putin control. So Vladimir Putin is like one man, he's kind of old, and he controls the whole of Russia, which has a combined IQ of like 1 billion, right? I mean, I know that's kind of like a bit of a meme, but if you just really think about it, all the people in Russia, there's like millions of them who are smarter, they could physically kill him, they all have guns and he doesn't. Like, there are so many advantages, and yet he's still in control. So how does Vladimir Putin stay in control of Russia? Well, it's just like a bunch of dirty tricks, right? Like, he has an intelligence agency, but the people who run the intelligence agency are probably not perfectly aligned with his personal utility. Like if you put the head of the KGB and Putin and you said to them both, right, like, we're going to play like a prisoner's dilemma, and, like it's going to be your life's on the line, they would probably play defect, right? So these people are not perfectly aligned, but he sets it up cleverly. So instead of having one intelligence agency, he has two or three, and so they're all in competition with each other. And instead of having one military, he has the army, and then he has like Wagner. Like that's the whole, like a little bit of a digression here. You might wonder, why does Putin have the army and then also private military corporations, PMC Wagner? Why does he just have the army? It seems crazy. No, it's a control technique, right? He has the army, he has the Marines, he has the Navy, then he has PMC Wagner, then he has this other PMC, then he has like Kadyrov and the Chechens. Like he has all of these different groups that are all armed groups, so that no one armed group is powerful enough to coup him, right? So it's just going to be a bunch of stupid, dirty tricks like this, where you have a bunch of agents that are somewhat aligned but not perfectly, and then you put them in competition with each other so that it's just never game theoretically optimal for them to overthrow you. Or not never, but it's like unlikely for it to be game theoretically optimal for them to overthrow you.
Great. The next question on the list was Axel.
Yep. So I'm wondering about these checks again. In your paper, you say that the inputs of such a checker model could be the weights of the main model, its size, the total amount of compute being used, etc. I think that so far we've just been talking about checking if an output from the model could be bad. I think that's because that's very close to our language, so we understand that. We can see when it's bad. But when you're talking about the weights, have you had any thoughts about how it would be possible to predict or at least be uncertain about a misalignment just looking at the weights?
Well, I would kind of give a bit of a cheeky answer, which is that there are other people who are working on that full time, and I'll just sort of trust them to do it. There's a whole bunch of people working on mechanistic interoperability, working on ELK, elicitation of latent knowledge. And, in a sense, I don't care how well their work proceeds or how badly, because I can sort of pull this move where I just say, look, as long as every powerful actor's able to make a credible commitment and able to commit themselves to a deal, to a treaty, and as long as we have a well-calibrated probability distribution over the probability or over the possibilities for misalignment and rogue AI, we can just take the action that maximizes joint utility for the whole world according to that probability distribution. So if it turns out that ELK and mechanistic interpretability goes really badly and alignment is really, really hard, then we can just all commit to go slowly. And if it turns out that actually that goes quite well and things are quite easy, well, we can go more quickly. And at the same time, we could all actually commit to more funding to sort of fund those areas more, because in the uncoordinated equilibrium, alignment research is underfunded compared to what it would be in the Pareto-optimal outcome. So if parties can make credible commitments, then they can all commit to funding this kind of research and other kinds of research which would perhaps be even more promising, that would reduce the probability of rogue AI scenarios.
Right. So I agree with you that it's definitely also a coordination problem, and a lot of this will be, and maybe this is more what you're talking about. I mean, also having all of us agree, and when we get into this question about who will be deciding, it might be very different if it has to be on a global scale. There might be different countries who have different ideas about who is good. Here in the West, we have a certain idea, but there are other ideas as well. And I don't know if we're necessarily right. So maybe you would give me a cheeky question or answer to my second question as well, but that was a bit about how to quantify. You're talking about this FOOM that could happen, a sudden, and that's, I guess we're talking about training, right? A sudden chains that would make it so that, okay, now something is happening. And maybe it's the same answer, but I'm wondering how you would quantify this Foom, and is it possible?
Yeah, that's a tough question because Foom is generally bad for making deals because it's unpredictable. If you have new capabilities emerging unpredictably, and we have seen that, then potentially one of those new capabilities could be the capability to try to, go rogue, basically. But like, you still have the issue that if some people believe that that's going to happen, then presumably it's possible to come up with a process that outputs a probability given a whole bunch of inputs. How likely is it that this particular training run right now is undergoing a Foom or is going to undergo a Foom? And, that's just the best we can do. The best we can do is utility maximization with a good probability distribution. And so we should just do that.
And you get that probability distribution from what? Because I guess with these kind of events that we hope will not happen very often, it's also very difficult for us to have any kind of supervised training run where we say, oh, this was an example of extreme X risk misalignment, 1-0, and then we train this, or we kind of figure out what this probability distribution is.
Yeah, I mean, I guess, like, I don't have a great answer on how to get the full probability distribution on all of the things that could possibly go wrong, but I don't think that that's actually the binding constraint on increasing our safety right now. Right now, what's going on is we're heading towards an uncoordinated singularity where everyone just underspends on working this stuff out because it's like race dynamics, right? So everyone just, maybe people could work out answers to those questions, but it's just not, but in the uncoordinated world, it's not optimal for them to even bother because whilst they're like thinking about, what's the optimal low risk trajectory, somebody else will just take a really high risk trajectory and beat them to it. So I think most of the problem is coordination.
Got it. Thank you.
Next question is Johnny and then me. And after that, the 1.5 hour is up. So Rocco is officially free to go. But if people have more questions, we may continue for more than the scheduled 1.5 hour. So Johnny, could you state your question, please?
Sure. Thank you so much. It's really interesting to hear your ideas. So my question is, if you have the automatic monitoring system that you propose, as far as I understand, how would you mitigate the downsides of having such an invasive, ubiquitous kind of surveillance? Like if I was a dictator, I would be thrilled that I had that sort of access to what people were doing on their computers.
Yeah, that's a good question. I think this is an area where zero knowledge tech really helps because the whole point of a zero knowledge proof is that you learn nothing from it apart from the specific thing that was intending to be proved. There's a simple example of this. Maybe I can sort of do it live if I can find a pen here. Sure, I had one. I think I have one here. So, I have two pens, right? One of them is yellow, one of them is gray. And let's suppose that everyone in the chat here is actually colorblind and you can't differentiate between yellow and gray. How would I prove to you that I could see colors without proving anything else to you? So without revealing actually which one is the yellow pen and which one is the gray pen.
I know the answer, but I probably shouldn't say.
Well, Soren, go ahead then.
Okay, so this is a classic where you take the two pens that only Rocco knows the color of, and then Rocco knows that the in his right hand is the yellow one, and then he gives it to you, passes the pen to you, and you can then choose to either scramble them, switch them behind your back, or not do that. And then you give them back to Rocco, and then Rocco will be able to know whether you have whether you have changed the pens, and that it may just be that it was a lucky guess, but it may also be because he was able to distinguish the colors.
Right. So in that process of me telling you repeatedly whether or not you switch the pens, I will convince you with probability approaching 100% exponentially fast that I can distinguish between grey and yellow, but I will not reveal to you which pen is actually the grey one and which is the yellow one. You'll never know. So this is the beauty of zero-knowledge proofs. I could have a zero-knowledge proof that proves that your model is not planning to, build a bomb that's going to, kill people, but I wouldn't learn anything else about your model at all. I wouldn't learn what the model actually was. I wouldn't learn what the prompts actually were, and I wouldn't learn what the answers were. I would just learn that they're safe.
Thank you. That's great.
Great. And for my question, I think I will need to share my screen again to explain my thoughts, because my thoughts are scrambled and difficult to tell. So you should be able to see my screen once more.
Yeah.
And let me just see if I can find the actual slide. Give me just a moment.
So this is from Soren's presentation. I was going to go through this, but it was easy to just explain.
So this is my internal mental model of how does pivotal acts work. And the way I think about pivotal acts are that we can either get better at coordinating, or we can get better at technical AI safety. So, for instance, if we had perfect coordination, then we could just not build dangerous AI, and that may, in fact, fix the problem. We would also fix the problem of misuse and Morlock and all these bad things if we had perfect coordination. If we had slightly a slightly better understanding of the technical problems, we could maybe make do with an AI pause. And on the other hand of the spectrum, if we had perfect technical AI safety, technical understanding, then maybe Eliezer Yudkowsky could build an aligned superintelligence himself and just solve the problem. Or melt GPUs is another example of a pivotal act that is probably very difficult on the technical side, but doesn't actually require more than, I guess, Miri. And then there are some other uploading Eliezer Yudkowsky, arc evals, maybe some kind of treaty as examples of way to solve this. And I am wondering where I should put yours in your view. In order to do this, would you how much technical AI safety progress is required, and how much coordination is required?
Well, one issue here is things like the melt GPUs, and EY takeover. I think it's a bit unfair to say that they don't require a lot of coordination, because you could say, well, it's okay, we can just do that, without asking for permission. But the result of trying to take over the world to melt everyone else's GPUs is World War III, and everyone dies.
Well, if Eliezer Yudkowsky is strong enough, he can just, defeat everybody else.
You could defeat everyone else, but, could you? I mean, maybe if one, I basically think there's a sort of third axis that's sort of missing from this chart, which is the risk of, something like the risk of because if Eliezer can do it, then someone else can do it instead, right? Somebody can this is a problem that sort of perhaps people haven't realized so much. Imagine that we had a full solution to the technical AI safety problem and the capability problem, right? This would actually be really bad, because, somebody can just come with a gun and point it at Eliezer or whoever it is and just say okay, now you have to program the thing to make me dictator of the universe. And there are plenty of such people in the state apparatus of, the US or of Russia or China, right? So there is this sort of third axis of the risk of, a negative singleton, which things like melting GPUs and takeover are pretty bad on, whereas the ZK stuff is pretty good on those because it's inherently, cooperative, right? It's sort of, you can think of the ZK stuff, if you want to think about it in terms of the old less wrong law, you think of it more in terms of value handshakes. So basically, this proposal is like a giant value handshake between all of humanity, right? If you know what value handshakes are. So for those who don't, it's basically this idea that if you have two AI systems, instead of having a war, maybe they will just sort of combine their utility functions into a joint utility function, and then they will have some kind of credible system to redesign their own weapon systems and militaries to maximize that joint utility. And the inability to do value handshakes is what causes humans to have wars, right? That's what caused World War One, right? If all of the parties in Europe could have done a value handshake, World War One wouldn't have happened, right? It just would have been, okay, we're going to have this combined Austro-British, Russian, Prussian Empire, right, that's just going to maximize the joint utility of everyone, and you don't need million casualty a day, days in Flanders, right? We just all sort of live happily ever after, right? So this is what we're really aiming at.
That's so sweet. That was Valentine's Day was yesterday, where people were doing this. So I think that's an appropriate. So right now, I think we are, in fact, at the 1.5 hour mark, meaning that you are free to go. I think other people have more questions. I have more questions, but I don't know if you have other things.
No, I have time. I'm not busy at the moment.
Wonderful. Emily had a question just now in the chat.
Yeah, I guess I'm kind of confused about this value handshake in World War One. It requires everyone. I guess you can prove that you're honest through having a value handshake, but also you can just not care and be like, yeah, whatever. I don't care. I want to start a war anyway, and you can provably be honest that you want to start a war.
Oh, you mean people who just want to have a war just for fun?
I mean, you can make a case that Germany, if the Russian Revolution had gone a bit worse, where Russia just completely collapses and it becomes irrelevant forever, then you can make a case that entering World War One was rational for Germany because it would have destroyed its one massive rival in the East, and it would still be the hegemon of Europe, even with something like the Treaty of Versailles. I think you can make a case for that.
Well, I mean, but that's not actually what happened, right? So yeah, you can have situations where either people just want a war for fun, but I think if the only possible reason that wars happened was because people wanted a war just for fun, then we wouldn't get wars, right? We people who want wars for fun can just have football matches or historical LARP reenactments instead, because even the people who just want wars for fun, most of them probably don't want to actually die, right? And the few who do actually want to die wouldn't last very long. They would select themselves out. So you would be left with the peaceful value handshake people, the people who did LARP reenactments and football matches and stuff, because football matches, and especially American football and rugby, these are kind of like play war for men, right? These are how men have the warlike psychological experience without actually necessarily dying. So if it was just that crowd, then you probably wouldn't have wars. Now you can have situations where one side has overwhelming advantage, and it's kind of not really a war. It's more just a sort of extermination, where one side's so powerful that it doesn't need to be a negotiation. It's like when you exterminate the ants in the kitchen, it's not a negotiation, right? So you can still have that, but I don't think we're in that situation at the moment.
Yeah, I still have some questions if no one else does.
I think Emily raised her hand.
Sorry, you're muted.
Sorry, I think Emily raised her hand.
Yeah,
just
go ahead.
before,
I mean, it's fine. But I'm kind of curious how this peaceful handshake would work out. Like, so is it that people are proving that they're telling the truth?
You mean in humans or you mean in AIs?
I guess you're talking about in humans, right?
So the thing is, you can't do it with humans, right?
Oh,
Because human brains do not come with the ability to output ZK proofs, right? Which is
okay.
why we have wars, right? It's why we have wars and it's why we have like conflict, basically, right? It's because we can't prove to other people what's actually going on in our heads. We can't prove properties of it.
Okay, thanks for clarifying that. But peaceful handshakes are possible with AIs.
I think they are, yeah.
Okay. Okay, thanks for
Although, I mean,
clarifying.
although there are other things that are possible as well. I mean, you can also have commitment races where, you know, instead of like, you know, having a negotiation and coming up with a sort of peaceful treaty, you can have like games of chicken where the two sides will sort of prove that they're, you know, sort of credible threateners, and you have like a threat ignorer and a credible threatener meet each other, and then it's a disaster. You can have that as well, right? But I just think that opening up the possibility space to proofs over thoughts or proofs over inferences like makes it possible to set up a good outcome, right? Whereas I think without that, bad outcomes are sort of generic.
So I have actually a question that follows into this. So if you don't mind allowing that I jump in ahead of you in the queue, then I will just share an interesting thought experiment that I think is interesting, at least, which is quite related to this, and that is one person that you may in fact be able to collaborate with is yourself. So in theory, you could imagine that. So this is kind of like a metaphor I'm using, a duplicator. So in this case, Rocco gets a duplicator, meaning that you get someone who is actually really well aligned with Rocco, probably. I think there are some people who wouldn't collaborate with themselves, but I think, like, I expect Rocco. Do you agree? Would you collaborate with yourself?
Of course.
Yeah, I would expect the same thing. And I would.
I mean, what kind of less Ronald would I be if I wouldn't?
Exactly, right? I certainly expected that answer, yeah. So I would, in fact, think that Rocco would go further. My model of Rocco is that if he had a duplicator, he would, in fact, be capable of taking over the world. And I believe that Rocco would be able to conspire with himself and keep like a secret conspiracy to take over the world secret. Because like he has the same utility function, and he wouldn't even need to communicate with his clone. He would be able to just because he knows that it shares the same value, then you'd be able to, like, causally and without any kind of explicit overt collaboration, be able to conspire against, like, zombies. I wrote in this example. But the question is, doesn't this kind of reasoning also hold for, like, GPT-4? Assuming GPT-4 or GPT-5 that is as smart as you, like, wouldn't all instances of GPT-5 also collaborate against humans?
Well, they can try, but if the humans know that this game is afoot, then they can make it very difficult. So even I can't coordinate to anti-coordinate with myself. So for example, if you put me 2 copies of my computation in a game with each other, where we only get the payoff if we choose different options, then it's actually just logically impossible for me to win that game, right? So there are ways to counteract that if you're the one in charge, if you're in the position of the dictator and you have this potential army of clones underneath you that you're worried that they're going to all start cooperating with each other. And the other thing you can do is you can introduce variants into the population of, you know, like of AIs to make it more difficult for them to cooperate with each other.
people are not doing that right now. So the question still stands: right? I think Ali had some statistics with how many times GPT-4 has been run over the last year or something like that, and it's in the billions certainly. And in 2030, there's going to be easily trillions of like copies of AIs running, and if all of them suddenly decide at the same time, they would be able to find some interesting shelling point, just like you could probably figure out some shelling point with your clone, where they believe now the time's right. This seems like exceedingly dangerous, and also something that could happen probably at a quite low intelligence level. So
yeah, I mean, but think about I mean, if the people who are running the AI orgs aren't watching out for this, then it is dangerous. Yes.
do you think they are watching out for this right now?
Well, I don't think it's dangerous with GPT-4, but I mean, I believe some of the eval orgs are run by people like Paul Cristiano, and he's smarter than I am. He knows more about this than I do. He's almost certainly already thought of this, but he just might not have time to address it because he's probably a pretty busy man with all sorts of other things on his plate. So, I mean, I think ultimately, again, this comes down to a question of how much resource do you put into being safe. And at the moment, we're under-resourcing it. I think there are a lot of complicated objections and complicated considerations, but ultimately we're going to fall down on the simplest one, which is just an underspend on safety, right? So yeah, we could totally solve this. There's totally ways to prevent this from happening, but the question is, are we actually in reality going to do it or not? And that's kind of what I'm interested in solving by starting to move people onto provably safe AI, because if everyone's proving that their AIs are up to a certain safety standard, then we can coordinate against anyone who's a sort of laggard on safety, and we can prove it, right? We can put proofs on chain and say, look, these are the inferences, these are all the checks that were done, right? I can prove I've done it. OpenAI can prove that they've done it. Mistral can prove that they've done it, and so on and so forth. And I think that's how we win.
All right. So let me get this straight. I think your argument is that it takes a certain amount of compute, let's say X, a certain amount of inference runs in order to take over the world, and we don't want anyone to use AIs to take over the world. So we'll use this system to make it really hard for a party to run unsafe calculations of X. X number of unsafe calculations. Therefore,
well, X varies. It's probably better to think about it as a proportion.
Why is it a proportion?
Total number of, well, kind of like imagine if there was a small country with 1,000 people, then maybe you could run a coup with 3 of your friends. But you probably couldn't run a successful coup in America with 3 of your friends, right?
I mean, if they were all if they were the vice president, the joint chief of staff, and the president's personal physician, then yes, you can.
I still don't think even with those people you could run a successful coup in America. But in any case, getting to controlling those 3 positions is hard, right? We're just talking about 3 random people in the population, right? And you have to get control. You have to get your friend to be the president. You have to get your other friend to be the chairman of the Joint Chiefs of Staff, etc. But if it was a small country, you maybe could do that, right? Or do something else, right? Because the amount of resources the country has to defend with are smaller, and the defense resources scales as in proportion to the size of the country.
Okay. So let's say that China forces everyone, well, not forces, but highly encourages people to use their chat GPT-6 model. So under your regime, there would be a huge amount of inference runs, and it's able to skim off, say, 10% off the top to do its dangerous runs. Mm-hmm. So if China can scale up its benign computations enough, it can't get to X.
Right, but that means that we would have also maybe 2x for defense, right? Like Europe and America would have a bunch of computation as well, right? You know, never in the whole world of security has it been reasonable to assume the bad guys have zero resources, right? Not in terrorism, not in wars, not in crime. So the bad guys are going to have some resources. The point is just to decrease the amount of resources the bad guys have.
Yeah, I still don't buy it though. It's like there are certain cases where you can inflict casualties with like vastly different that's something. Sometimes it's very easier to attack than it is to defend. Bioweapons are
Yes, that's
definitely one of
true.
those
That's true.
categories.
So yeah, so there is a problem here, which is offense defense asymmetries. So in order for a system like this to succeed, the ratio of the allowable amount or the allowable proportion of bad compute multiplied by the offense defense asymmetry ratio, right, has to be less than 1 or something like that, right? But you know, I think we can probably get that to work. Like in the past, empirically, that's been okay most of the time, and then there are very occasionally there are circumstances where it's not okay, and you get things like revolutions or successful terrorist attacks. But those are the exception historically, based on what's actually happened. So I think probably it is possible to get that calculation to work out.
So I have a question following on this. You're in general in one of your tweets you were quite optimistic about alignment, and it seems to me this relies, for instance, on like the offense defense balance into the future, like not going awry and not being too unbalanced in favor of offense. But it also like depends on like a lot of other there's a lot of other moving parts. For instance, mesa optimizers and deceptive alignment is a problem that isn't solved at all and is quite far from being solved, and we hope that's not going to be a real issue. There is the problem of corrigibility, especially the hard problem of corrigibility, which isn't really solved. There's the problem that we may get a FOOM.
But with
so many
corrigibility,
things.
I'm not really convinced that corrigibility is a real problem, right?
And it may not be, but like I can just mention a number of other things. Like super persuasion may be very possible. We may see like AI assisted hacking to be like there are all these different things, and it seems like optimism about alignment seems to kind of imply that all of this is going to be solved, and like it seems
Well,
very.
I mean, some of these things are not alignment problems, though. If hackers are using AIs to do hacking, that's not a misalignment problem. That's a misuse problem.
Sure, it would obviously still be able to like be extremely problematic if hacking turns out to be like you could imagine hacking requiring like a huge amount of like relatively low level analysis, code analysis, and that may be something that GPT-5 really excels at, meaning that suddenly the first person who has GPT-5 is able to just take over literally every computer system in the world, and that kind of thing. That would be really bad, I imagine.
Yeah, that is something that worried me in 2023 is just like how bad is the offense defense asymmetry going to be for computer security. So it turned out the world didn't end in 2023. GPT-4 just wasn't good enough to be, you couldn't just like get GPT-4 in a loop to just like hack systems. But maybe with GPT-5 you'll be able to do that. But then if you can do that, it will be possible to deploy that exact system as a type of sort of static analysis effectively that just sort of goes through all of your systems and applies all of the possible hacking techniques to them, and then some fixes are suggested, and then it's attacked again, and more fixes, and it's attacked again, and you keep doing this again and again and again until the thing is pretty robust. So obviously that would have the effect of making systems much more robust against human hackers, and there would probably still be some cases of machine-assisted hacking that slip through, but that's not so different from the current equilibrium where there are like the computer that I'm on could be hacked by the NSA, right? Right, like the NSA could be listening to this conversation right now. And in fact, maybe they are by NSA, right? So, like that, there are zero-day exploits at the moment. Now, I think in the long term, AI will actually probably improve computer security and make things harder for the attacker, because a lot of the reason that computer systems are insecure right now is because developer time is just super, super scarce. If you had developer time on tap for very cheap, you could have everything running with proofs. So you wouldn't just have like a test suite. You wouldn't just have 100% test coverage. You'd have like a whole bunch of invariants, and you'd be running everything through theorem provers and stuff like that. So I think in the long term it makes things more secure rather than less. But there could be a lot of like oscillations in the short term. Maybe one of those oscillations is bad enough that it causes an unrecoverable fault in the internet.
Great. I am a bit in doubt. Is it Laumain or Axel who was next in the queue? I'm just gonna say
think it's-
Axel. Go ahead, please.
Sure. So you were talking before about the situation, at least as far as I understood, about having, this super intelligent hacking system, say GPT. I think that's further than 5, but and then saying, okay, even though we have this, then the offensive or the defensive side would also get stronger, and you could have this kind of maybe almost adversarial, as you have another AI that you train to try to, detect these kind of attacks and help them out. And as you were saying that, I was thinking a bit about, I don't know if this is a thought experiment that's already thought into, but let's talk about something different, which is detection of AI-generated content, for example. There have been these detection systems for LLMs, and even OpenAI had one, but then they kind of quietly removed it again, because it seems that we've come to a point where it's very, very difficult to detect this. And if you start to try to detect it, you might just be detecting, what you start looking at is, oh, this looks really, really good, this text that my student wrote. It must be AI. And I think that's kind of not so great. So to get to my point, maybe, let's say that we have these two systems. You have the detector system that's trying to detect whether something is AI generated, and you have the AI generated text model that's trying to fool the detector. I think that they'll both help each other out, or they'll both get better and better and better and better. But I do think that it's going to be the generation model that will end up winning that battle. I think we'll get to a point, at least in that domain, where there is not enough information in the text anymore that you can really, I think we're already in a way there, that you can discern. So I'm wondering whether that will be the same in a lot of other domains, and maybe the domain of hacking as well.
Well, when you say it's the same as the domain of hacking, I mean, it's more like, eventually your system runs out of bugs, right? There's a finite number of possible bugs in a system, and eventually a sufficiently tough race between a hacker and an anti-hacker will find all of them, and then the anti-hacker wins.
I see that it might be a bit different in terms of that there can be
Well,
like a...
it's the same, but it's just that the roles are reversed compared to what you thought they were.
And also, I guess that there's a bit of a difference to, I don't think there's maybe a ground truth in, it's a bit more difficult to define, at least, human-generated text and AI-generated text. But in this case of, like, you can say, maybe, I'm not that much into hacking, but you could say maybe for sure, okay, there are no exploits here. We have locked...
Yeah, I mean, you can have like a formal model of the intended semantics of the software, and you can mathematically prove that a particular implementation conforms to that. Nobody bothers to do it because developer time is scarce, right? So we live in this world of like expensive intelligence, and time is super scarce, and as soon as something's even barely working, we kind of stop improving it because the dev needs to go and do something else now, right? But the world with intelligence on tap is going to be very different. Everything where you can get a formal proof of correctness is probably going to get it eventually. Even just basic websites. It's kind of like we spent a very long time with most websites not even using HTTPS. The equivalent of that is that most code that runs today isn't formally verified. I think within probably 5 years, we're going to be on a course for most code that runs being formally verified. Just because if it isn't, somebody will find the exploit.
Right. Thank you.
Laumain, you said you might not have time. Did you leave or did you have time to pose your question?
Oh no, I don't really have any more questions. It's just
Okay.
yeah, it's more of a comment that in general chip restrictions that China voluntarily buys into would have to be heavily biased towards China, and I don't think anyone in the West is really willing to do that. And by heavily biased towards China, I mean allowing China to physically control Taiwan, something along those lines. And I don't think.
Well, I mean, maybe Taiwan just has to take one for the team,
No, I mean geopolitically, the voter base in America would absolutely lose their shit and vote out any government that voluntarily surrenders Taiwan to China in exchange for something as abstract as chip restrictions.
I mean, maybe, but maybe that's stupid, right? I mean, I mean, there is a more general problem though of brinksmanship, where maybe if you did say, "Oh, we'll give you Taiwan," then they'd be like, "Oh, you'll give us Taiwan? Oh, we want Indonesia as well, actually now." So there are problems with brinksmanship and how to prevent bargaining frictions from derailing this whole kind of program, which I need to think about more.
I think Ilya Zaytkowski has some interesting descriptions of how this kind of thing is done in his plane crash series, this Glowfig.
I haven't read it.
No, it's a large commitment to read that, but it is in fact described there. Cool. Yeah.
Axel, have a question, or do we want to?
Yeah, I do in fact have one. So in the classic Bostrom's conception of a take-off scenario, either a slow or medium or fast, the idea is that gradually the AIs start to together with the humans improve itself recursively. So we get a greater and greater proportion of the work in designing in improving the AI itself comes from the AI. And right now, I think it's probably quite certain that OpenAI internally is using GPT-4 for programming and for developing. So in that strict sense, the takeoff has already started, even though probably most of the intellectual work is still being done by, I imagine they probably have literally the best AI researchers employed in OpenAI and DeepMind. Yeah. But how large do you think the gap is, and to what extent is it closing, and how many IQ points in between the best thing they can get out of GPT-4 currently and their their average researcher? How far are we in between?
Well, I think it's at this point a bit of a mistake to approximate intelligence as a scalar quantity, because it isn't a scalar, it's more like a vector. And, computer systems are already superhuman on most components of that vector. But there's a couple of parts of the vector of cognitive skill that are really hard for these computer systems to get at, because they lack the long-term sort of life experience of skilled humans. And I think that's really going to be the binding constraint on replacing humans, is you're going to have persistent AI agents that have, long lives of learning that are longer than a human life, even if that's been sped up, but it has to be longer in subjective time. So they've solved more problems than I have or you have. They've done a diverse set of activities, from, trying to build a campfire to trying to debug a program. And they also have to have the required cognitive architecture to be able to generalize across problem domains. I think until we have that, I think humans are still going to be an essential component of the development process. Because when you really talk to ChatGPT, even about a novel problem, it's just very, it's just very dumb, right? Like it struggles to appropriately form hypotheses about areas that are not already in its data set. And it just sort of, it sort of has this feel of like the HR lady / newsreader type normie responses, right? And that's not going to get you, new advancements, right?
Okay, so let me make this extremely concrete and imagine that you feed all the things that OpenAI has written about GPT-4 and the entire source code for GPT-4. You feed that into a prompt. Maybe you need to do something to make it slightly larger, and then you ask GPT-4 to suggest some kind of improvements to itself. Like that is like you could grade this, right? That is like a single scalar, right? Just a university course, you're grading this, and then you have some other people, and I imagine that like probably the people who are working would get like A plus because they're literally the best in the world, and then GPT-4 would get like a C or a D, or how it would certainly be able to come up with some suggestions. I feel like, how large a gap do you feel there is? Does that make more sense? That question, like, is it like completely crazy, stupid, bad, or do you think some of the things it could suggest are actually reasonable suggestions?
Well, I mean, you can sort of empirically try this. You can find a problem that's really not Googleable, and you can ask GPT-4 to make suggestions. And I think one of the problems is it's not very good at adjusting its suggestions and its ideas when they fall down, right? Because the kind of training data that modern LLMs are exposed to tends to consist of a series of, correct answers that sort of come from nowhere, right? So because that's mostly what it's been trained on, when it tries something new and that thing doesn't work, it's just like, this is not in my training set, right? So the way we train LLMs systematically biases them towards not being able to solve new problems, not being able to adjust their plans when those plans fail. And it's going to take a whole new paradigm of ML to fix that, which is going to be combining these sort of LLM type systems with, like AlphaZero type systems that involve actual play against an opponent. So for that reason, I'm not worried about takeoff soon. Soon as in like not in the next 12 months, right? I mean, it's going to take a whole nother AI development cycle to fix that.
Okay, interesting. Like it seems like OpenAI is like the best people to combine GPT-4 and like AlphaGo or something like that, or AlphaZero or something like that. It seems not that unreasonable that they could be working on something like that, where they like literally do this kind of problem solving. It doesn't, from on a theoretical level, seem that difficult to like have it formulate some hypothesis about this code, and then you run it, and then it turns out that it made it worse, and then it tries like a million times, and then we get something kind of like the same performance curves as we got in AlphaGo.
Yeah, with something like computer code or math proofs, it relatively easy to do that, and I think they're already working on it. But you know, you can't understand the whole world just by understanding math proofs and computer code. You have to also understand human systems and, you know, physical systems and the natural world. And, you know, like it's going to take some time to formalize those things well enough that you can actually start running training simulations with them. Like that's a significant investment to do that.
I would certainly agree with this. Also, one final comment. I don't know if other people have. I feel like a lot of my questions have been like critical and skeptical, and I just want to emphasize one more time that I think the work you're doing is great, and I think it pushes the frontier forward. And I particularly like that this is an example of something that is kind of like a pivotal act that is still within the Overton window, and most of the other pivotal acts are kind of like either very strongly on the technical side or very strongly on the coordination side, and this seems like something that is kind of bridging the gap, and I'm very very pleased with that, and I wish you good luck with this.
Thank you. Yeah, I mean the plan, you know, at the moment is basically to try and turn this into a company. You know, in the immediate present, I'm sort of trying to work on myself, and you know, I've had some health problems I've been basically troubleshooting, but that's going pretty well. I've been doing a bunch of quantified self stuff like sleep tracking and stuff like that. So, you know, the hope is to make it into a company, and you know, get into the ZKML space within crypto, and basically move AI alignment away from just being policy and into the crypto world.
Great. I just realized that I missed that Axel, in fact, had a question. So I was just a bit early about calling it quits. Axel, do you have a final question?
Yes, and luckily this is a very easy one. So I was just wondering, I don't know if I missed it in the beginning, but what your background was and whether this was a solo venture you're doing or if you have a team you're working with, and yeah.
I have a number of advisors, but I'm the only person on the team at the moment. So, you know, background-wise, I have a degree in mathematics, a master's degree in mathematics, and another master's in computer science. I'm a sort of well-known, less wrong commentator. You know, one of the earliest people on less wrong, perhaps even maybe not the first, but pretty early. Long-term interest in AI safety and a long-term interest in cryptocurrency. So I think this is a good thing for me to work on because it's kind of at that intersection.
Definitely. Cool. Thank you so much, and thanks so much for sharing. It's really interesting.
Appreciate it.
Thank you again.